Finding horizontal and oblique asymptotes of a rational function. In order to determine whether a function has horizontal or oblique asymptotes, if any, we need to compare the degree of the denominator with the degree of the numerator. So if the degree of the denominator is greater than the degree of the numerator, first of all, we call this a proper rational function. Just like you can think of a proper fraction, for instance, 4/5 is a proper fraction because the degree, or in this case the number in the denominator, is larger than the number in the numerator. It's analogous to that. So if the degree of the denominator is greater than the degree of the numerator, we're going to have a horizontal asymptote. In order to find that asymptote, we actually don't have to do any work at all. We just know it will be a horizontal asymptote of y equals 0. So there's no work to do to determine it. So let's look at an example. If we have a function f of x equals x plus 2 over x minus 3 squared. So we can see the degree of the numerator is 1. The degree of the denominator is squared, is degree 2. So since the degree of the denominator is greater than the degree of the numerator, we will have a horizontal asymptote at y equals 0. No work to do. Now, if the degree of the denominator is equal to the degree of the numerator, we call this an improper fraction or an improper rational function. It's going to also have a horizontal asymptote, but we have to do just a little bit of work to find it. We're going to divide the leading coefficients of the numerator and the denominator. So for example, if we have a function g of x equals x squared minus x plus 1 over 3x squared plus x plus 4. So in this case, we can see numerator and denominator are both degree 2. The degrees are equal. So if we look at the leading coefficient, so our coefficient of our leading term in the numerator is 1. We can see the leading coefficient in the denominator is 3. So if we divide these, we're going to get our horizontal asymptote at y equals 1/3. Now, if the degree of the denominator is exactly 1 degree less than the degree of the numerator, this is also an improper rational function. We're going to have an oblique asymptote. In order to determine an oblique asymptote, we have to perform long division. And just note, when you perform the long division, we ignore any remainder. All we care about is the quotient. So for instance, if we're given a function h of x equals x cubed plus 1 over x squared minus x plus 1. So we look at the degree of the denominator. It's exactly 1 degree less than the numerator. Denominator's degree 2, numerator's degree 3. So we know we're going to have an oblique asymptote, and in order to determine it, we would perform long division. So we do x squared minus x plus 1 divided into x cubed plus 1. So when we do that division, we would get a quotient of x plus 1. And we wouldn't care about the remainder if there was a remainder. All we care about is the quotient, so we're going to have an oblique asymptote at y equals x plus 1. And then finally, if the degree of the denominator is more than 1 degree less than the degree of the numerator, we will have neither horizontal nor oblique. So you can have either horizontal or oblique or neither. So obviously there's no work to do, nothing to find. So an example of this would be f of x equal to 2x to the 5th over x cubed minus 2. So if we compare the degrees here, the degree of the denominator is more than 1 degree less. It's 2 degrees less than the degree of the numerator. So that means we have no horizontal or oblique.